Hello everyone, welcome back to our channel. Now we are going to discuss about river and man problems in one dimension. Two dimensions it is coming in motion in a plane. It is the last part from the motion in a straight line chapter. So in this we are going through the different cases when the man is swimming in the river. Even you feel you are swimming in the river. What is the velocity of the man, what is the velocity of the river, and what is the velocity of the swimming man with respect to river we are thinking. First case, see, case 1, man is swimming downstream. Downstream they will mention in problem, but we should think the man is swimming along the water flow, along the river flow. So river and man both are swimming along, both are going along the same direction. In this case, see, V is the velocity of man with respect to river. It should be right VMR. Like that, U is the velocity of river. Velocity of river. Then it should, but we have to find out in this case what is the velocity of the swimming man. See, VMR equals to, they have given V. It should be right Vm minus Vr equals to V. But we want velocity of the man Vr plus. In the case of downstream, what is the velocity of the swimming man is the velocity of the river plus velocity of the man with respect to river. One problem we are doing here. See, if velocity of the man with respect to river is 20 kmph, then velocity of the river is 10 kmph. In this case, how to find out the velocity of the swimming man? Vm equals to velocity of river, they have given 10, and V is the velocity of man with respect to the river 20. So downstream means immediately we can take it Vm equals to 30 kmph. Here you should consider theta equals to 0 degrees only. But anyway, it is one dimensional motion. Downstream means we can take the expression. Then one more case. Second case is the upstream. In the case of upstream means the man is swimming. The man is swimming opposite to the river. See, the man is swimming like this. But this is the velocity of the river we are representing with small u, and this is the velocity of man with respect to river we are taking V. But here angle is between them, angle is theta equals to 180 degrees. So velocity of the man with respect to river, that is V plus V man plus VR. So instead of this we are writing V equals to Vm plus velocity of the river is U. Finally Vm equals to V minus U. So in the case of upstream we are getting the negative sign. Why? The person is swimming opposite to the river. We do one problem also. If V equals to, in this case, 50 kmph and U is the 5 kmph, then what is the velocity of the swimming man? 50 minus 5 is the 45 kmph. So these are the few problems when the man is swimming in the river. Otherwise, when the boat is going into water, we should remember that here don't confuse. U is the velocity of the river. And when the person is swimming, they will mention in that the velocity of the man with respect to river we should consider V. So we can find out that swimming man velocity is how much. In the case of downstream, we are getting the positive sign, and in the case of upstream, we are getting the negative sign. And these two are the examples belongs to this. More problem we are discussing here. See, first the man is swimming along the direction of the river. Along the direction of the river, he travels a distance d and he took t1 seconds. See, he is moving. This is the V is the velocity of the man with respect to river is V, and this is the velocity of the river we are taking U, and he covers how much distance d. How much time he will take? You know that time equals to distance by velocity. velocity of the man. Already you know that in downstream, that velocity of the swimming man is how much? V plus U. Then what happens? After covering D distance, he is coming back to the same position. Suppose he has started at A and reached to the B. Then once again he comes back to the A. And in this case, how much time is there? D by, now he is swimming opposite to the river, means we are getting V minus U. If the question is total time for to and fro motion is, we are taking T1 plus T2. In both the cases, which is common? D is the common. We can write it 1 by V plus U plus 1 by V minus U. After simplification, total time to travel from A to B to B to A is D into, which is cancel here, V minus U, V plus U. U cancel, you are getting 2V by, the LCM is A plus B into A minus B formula. We can apply this V square minus U square. I think you understood this question. The man is swimming D distance along the river downstream. Then he comes back into the same position. At that time, second condition, he is swimming opposite to the river. So total how much time he takes to coming back to the same position? That formula we should remember directly. T equals to D into 2V by V square minus U square. Now we are going to discuss one problem also based on this. See, if D equals to 40 meters, velocity of the river with respect to, velocity of man with respect to river is 4 meters per second. This U is 2 meters per second. In this case, how to find out the time? Direct we are taking, this is the 40 meters. Then 2 into 4 by V square, 16 minus 4. So T equals to 40 into 8 by, this is the 12. 4 2 4 3. Then 80 by 3. 26.6 seconds. Otherwise 26.7 seconds. Total how much time he will take to complete the path he started and coming back to the same position? 26.7 seconds. Thank you everyone. Here motion in a straight line, there are different parts. This is the last part, motion of the swimming person in the river. If they are mentioning boat also, we can take the same condition, but we concentrate on with given data with respect to river or velocity of the river and that one. Downstream means we can take positive and upstream means we are taking the negative. Same problems we are discussing in motion in a 2 dimension, our next chapter. Thank you. Please subscribe my channel.